Hello again, we are here with another physics lecture and we are going to talk about the position and velocity vectors. We are going to describe the motion in 2 and 3 dimensions. For motion in 2 dimensions, all the fundamental quantities of kinematics, such as position, displacement, velocity, and accelerations, are vectors. A good way to think about the motion of an object in 2 dimensions is in terms of its x and y exponents. By considering components, for example, the vector forms of the equation of 2-dimensional or 3-dimensional motion can be expressed as equations of the motion in one direction. We have derived equation of kinematic that describe the motion of objects in one direction. However, many objects move in 2 or 3 dimensions in real world. For example, the path of the ball tossed in the air follows a 2-dimension. Right? So the 2-dimension allows or follows the 2-dimension arc. A ship navigating a river can move forward, backward, and left and right. All of the fundamental quantities of kinematics that we have explored in 1 dimension can be written as vectors in 2 or 3 dimensions. These quantities include position, displacement, velocity, and acceleration. In 1 dimension, we have the average velocity is the v, average is delta x or delta t. In 2 dimensions, the average velocity vector is the v and it has average v is delta r or delta t. The initial position of the lizard is Ri and it moves to position Rf. Notice that the average velocity vector is in the same direction as the delta r, but its magnitude is different. So the magnitude, it means the length. So we have another crazy graph that shows the path that the lizard follows as it moves in 2 dimensions. So what does it mean? It means instantaneous velocity vector is found by taking the limit as delta t approaches 0 of the average velocity vector. So we have the v vector limit as delta t approaches to the 0. So we have delta r divided by delta t or dr dt. So the direction of instantaneous velocity vector is always a tangent to the position function. When 2 vectors are equivalent, their components are equal in magnitude, right? So when this one is equal to that, so I mean the ax equal to bx, ay is equal to bi. So you can write the equation of kinematics as vector equation and then break them in component forms. Thanks you for watching.